So, hi everyone. So, today we would be looking at the third contract of our project, and then we would be writing some tests for those contracts because since the first session of this series, I am emphasizing on the fact that whenever we deploy any contract on the actual blockchain, it is impossible to go ahead and modify those. So, keeping that in mind, writing tests for those contracts becomes a very important task because if there is something to fail, it is better that it fails during the test than it failing when we have actually deployed it on the chain. So that is the main agenda for today's session. Complete the third contract, write tests. Then we would be looking at the front end code. I don't think we would get time to actually write all the front end code ourselves. So I'd be copy pasting code and try and explain as much of it as I can. We would be definitely focusing more on ethers.js library and where all the implementation of that library is being used. That I'll make sure to go in great detail. Apart from that, I would be focusing more on deploying the contract. So that is how the flow of today's session would be there. So we start with the third contract, we dabble into ethers.js, then we uh, quickly go through the front end of the code, and then we see how we can deploy it for ourselves. Are we good? Can you guys hear me? Just give a thumbs up so that we can start the session. Okay, amazing. So I uploaded the code repo yesterday. So how many of you went through the third contract? If you guys found anything interesting or anything you might want to share, you can just go ahead. Anyone? Okay, no worries. So let me share my screen and we'll get started with today's session. Yeah. Can you guys see the screen? Great. So yeah. So this is the third contract that we have. This is property factory.sol. So let us go ahead and look at it line by line. So the first two lines basically, I mean, the first two lines are essentially there in all the contracts. We just specify the version of Solidity that we are using, and on the top we just specify one of the licenses. Then we are importing a contract from OpenZeppelin. So in yesterday's session, we discussed what Open Zeppelin is. So it is basically a repository of a lot of contracts written by good, like cautious engineers, contract engineers, and all of those contracts have been audited by another set of engineers. So basically, if we are importing any contracts from Open Zeppelin, it is very low chances that the contract that we write would end up being faulty. So it is generally a good practice to use whatever available contracts there are. And in the last class, while discussing about tokens, we also saw that there are two important libraries or contracts that we need. One is the ERC20 standard, and the other one is this ownable.sol. So let us look at this code now. And second, yeah. So here you can see now we are creating this contract, which is property factory, and that is extending the ownable contract. Now within this contract, firstly we have a properties, which is an array of address types. So whatever addresses we have, like that will be getting stored in this properties array. And apart from that, like we have this mapping from address to boolean, which is operator. So this mapping is basically to check whether the particular address is the operator or not. So when in the last session we were seeing how the project functions, we saw that operator gets more functions than a normal contributor or an investor. That is because an operator should have the say authorization to create new properties, list new properties, and finalize the contribution for them as well. So that is why we have this mapping called is operator. Apart from that, we have a few events as well. So and like these events are like operator added is an event that will emit to the JavaScript when an operator is being added. Similarly for operator removed and property created. And in all these the first two added or removed, we are passing a parameter which is the operator parameter. So obviously if that address will be an operator, we would be like calling the event or vice versa. Apart from that, then we are actually calling the constructor. So this is the constructor of our actual property factory.sol, and this ownable is the constructor of the ownable contract. Since we are extending our property factory onto this ownable contract, we need to call our constructor as well as and the constructor of the ownable class. So we are passing the message dot sender in the ownable contracts constructor. And as you guys might know till now, that message dot sender is nothing but the address of the address that is calling that particular function or that particular contract. So now let us go ahead and look at the functions that are there. So firstly is the add operator function. And this external over here again is because when we are calling this add operator, we are actually not uh, focusing on this contract, but this contract can only be called by a contract which is defining our owner. So since it is an only owner modifier, and here in this contract, yeah, this only escrow is similar. Wait a second. Yeah, so that is there, and because it is like similar to this one, so whatever is the escrow account or the owner account, those will be able to add new operators and remove the existing operators. So here you can see we have two required conditions: one that the operator address cannot be zero, and the other thing is that is operator should be false, because if is operator becomes true, then we would actually, it is already an operator, so we cannot add it again as an operator. And once we both the required conditions are met, we write another line that now the is operator should become true, because we want the that particular address to be added as the operator. And finally we are emitting the event that operator is being added. And only owner is actually like a modifier of this ownable contract. So whenever we import the ownable contract, we get only owner as a modifier, and that's what we are using. So here now again remove operator is very similar. Like if it is already an operator, then only we can remove that address as an operator. If it is not an operator in the first place, there is no question being asked about whether it can be removed or not. Apart from that, we have this create property function, which again just takes in the parameters of goal, duration, title, metadata, token name, token symbol, and all. And what it does is it checks the escrow address, and it checks whether the message dot sender is an operator. And once it does that, it creates a new escrow property, and that has all the parameters that we passed over here. So that's what is happening over here. And finally, once the property is being created, we add a new escrow address. And see, this address of the escrow is actually the owner, because our case is not that decentralized, because owner is only the escrow. But if we are scaling this higher, then we can create a function wherein a third party can be the escrow, and those addresses can be modified accordingly. And now we do properties dot push escrow address. We want to add the escrow address in our properties, and finally we emit the event along with all the details. And now we have just two functions. Get property count, it just tells us a number that how many properties are there. And get all properties is a function that will help us get all the properties of that particular uh, like all the properties that we have listed. Fine till now, like this contract. Okay. And another thing to note is that like we are passing this message dot sender over here because whoever is creating that property, let's say tomorrow I want to list a property. So whenever I list the property, I automatically become the operator for that property. So we can have multiple operators as well. Although for simplicity, when we actually deploy the contract, we'll try and keep one operator and one investor. So now we'll go ahead with writing the tests. But before that, just simple diagrammatic information about how all this ethers.js works and why do we need to use ethers.js. So just a second. Yeah, I hope you can see. So whenever we are interacting with a website, the general workflow is like we have a browser, we have a front end of the website, which can be written in HTML, CSS, and JavaScript. And finally, we have a backend where we are storing all the data to make sure that the data doesn't get lost once it is done. But whenever we have a decentralized app, apart from the backend, we also have the blockchain. Blockchain is basically where we are writing our smart contracts. So till now, we have written all the logic for the blockchain part of our real estate app. But to interact, to make sure that it can interact with the front end, or in general, whenever we are writing any code in JavaScript, there are various libraries. We can use web3.js, we can use ethers.js. Web3.js is a library that was quite popular earlier, but nowadays people are moving towards ethers.js more. And apart from that, there are various new libraries as well. Wagami is there, but ethers.js is generally considered like a sweet spot between like not getting too redundant like web3 and not really recent like Wagami. So you can check Wagami also out. It's a really good library if you want your JavaScript code to interact with the Solidity. But for now, we'll be looking at ethers.js. So it is basically to help our JavaScript code and our smart contracts interact with each other. So to do this, I have a small contract which is not related to our current one, but just to make the concepts a bit more clear, we'll try and do that. So just a second. So this would actually be coming in handy when we are writing the tests, because tests would be written in like tests would be written in JavaScript. So that is why covering ethers.js right now makes the most sense. Yeah. So here we have our packages. So we are using three packages over here, .env, ethers, and a prompt. So we'll just go ahead and run an npm install to make sure that all our packages are installed. So this finally deploy our code as well. But for now, what I want you guys to go through is like you can create an alchemy account. So Alchemy is a website where you can get some help in deploying your decentralized apps. So it provides us with an RPC. RPC in Web3 is basically a remote procedure call. So whenever our contract is trying to connect with the actual Ethereum blockchain or some Ethereum test net, Ethereum mainnet is the one for which you need to run with actual ethers. And apart from that, we have different test nets like Sepolia and other test nets as well. So if we want to connect with them, we need a remote procedure call, and that remote procedure call is provided to us by Alchemy. So that is how the code works. Just give me a minute. I'll try and share the website of Alchemy as well. Yeah. So you can just go ahead and create a simple account on Alchemy. This will create like a your name first app kind of a thing. And what we want over here is to copy the endpoint URL. Now, just directly copy pasting the endpoint URL is really not that safe, because here you can see I have an API key which is there. But whenever I'm trying to deploy my code, I don't want this API key to get leaked. In this case, it is fine. It is not that important. But when you're actually deploying projects which run on the mainnet, you want your API key to be protected. So in that case, we what we do is we put that in a environment variables file .env file, and then we add that .env file onto our uh, like get ignore file, so that doesn't get actually pulled on GitHub. So what we are going to do is, firstly, we'll try and resolve all the imports, and then just try and set up your Alchemy as well. It is a really easy process. You don't need much like it is just go ahead and sign up with your Google account, put in your phone number, and you'll get a window like this. While selecting the network, you should choose Ethereum. Oh, wait a second, I'll just create a new app right now. So once you're done with setting up your account, you can create a new app. That's when you get a window like this, and you can just give a name like learning ethers.js. That is fine. And project type, anything you can give. Now choosing chains, here we have to choose the Ethereum chain. Click on next, and it gives us a lot of APIs. We just go ahead and click on create app. That will give you this page that I showed earlier. And again, I have a different API key. I can use any of these. So what these will do is these will help me connect to the main Ethereum. I can use any other RPC. There are some free RPCs available as well. But because this actually signs in with my Google account, not many people can use this link. Only I can use this link. So, which is why working with these is a bit easier. And otherwise, if you use some publicly available RPC, you might just get rate limited, because there are thousands of people who are using that same URL to connect to the network. Is RPC clear, guys? Can we go ahead and use this RPC? Just give a thumbs up. Okay, great. So now we'll actually go to our VS Code window, and we'll try and set up everything. Yeah. So as I told you, we have a .env example. So this file can actually be pushed to GitHub. Why? Because this doesn't have my Alchemy API key. So I can push this to GitHub, but what I don't want to is a .env file. So I'll create this .env file. I'll just copy and paste this, and wherever it says Alchemy API key, what I'll do is I'll copy my API key from the Alchemy website, and I'll just paste it over here. So once this is done, I can go ahead and start. So I'll need some packages. What package are we learning? We are learning ethers.js. So we'll go over here, and we'll just import ethers.js. And there's a simple syntax that we need to follow. It is this, like const ethers is require ethers. That tells the JavaScript to import ethers. Now, to like, okay, let me just quickly share the documentation before we move forward. So in yesterday's session, again, I told you that the best way to learn any new technology that is out there, or any language that you want, is to go through the actual documentation that their team has provided. So similarly for Ethers, which is a library for JavaScript, there is documentation available online. I'll just quickly share the link in the chat as well and share the screen. So you can go to this link yourself as well. I'll just share it. So yeah, here you can see import ethers from ethers. That will help us import anything. And if you only want to import certain features, we can put it like this. Apart from that, you can see these functions: a provider function, a signer function, transaction function, contract function. A lot of these functions are there. But now here comes the main part: how to connect to Ethereum. That is being done by a custom RPC backend. So this JSON RPC provider is what I told you. So when we went to Alchemy and copied that link is actually our RPC provider. That is the JSON RPC provider. So we'll just copy this code over here. And if I just return to my JavaScript window, I mean my VS Code window. Yeah. So I'll, for the connection, I'll first need to give the provider, like provider is something and some URL is there. So this might beg the question, like what this URL is. So this URL is nothing but my Alchemy URL. So as you can see over here, wait just a second. Yeah. So here, as you see, like th.mainnet.alchemy/v2. This is all the generic link. So tomorrow, if you create a RPC via Alchemy, this part will remain the same. What will change is the Alchemy API key. Now, in order to process this env, and in order to make sure that JavaScripts understand that this Alchemy API key is the same one that I have in my .env file over here, what I need to do is I need to import one more library, which is the .env library. So that we'll do over here, and require .env.config. That just helps our JavaScript understand that, okay, whenever I click on this Alchemy API key, I'll get, so right now it's not working, but essentially it will work when we finally go ahead and deploy. So wait a second. Yeah, sorry. So now we need to write a function. So in order to, like, our job for this particular code is simple, that any address that we find on the internet, we should be able to get the balance for that particular address. So we'll just take any random address. You can take anyone from Etherscan. So just a second. Etherscan. One second. Okay, yeah. So let me just share what website. Like, so this is some guy on the Ethereum network, and that person has 7.043 something something ETH. So what my goal is, that whatever code I am writing, I should be able to give this address and fetch how many ethers does that person have. So for that, what I'll do is I'll just copy this address, and onto my VS Code window again, I'll just create a const called address, and I'll paste the address over there. So just copy the address and paste it. Now, in order to write like the logic for getting the balance and finally updating it, what we need to do is I'll just show you first the documentation for that part. So yeah, user interaction is where you can find a lot of other methods and functions that we would be using. So again, to get balance, yeah, here it is given. Interacting with the blockchain, querying it. So balance is equal to await provider dot get balance ethers dot eth. This when we are writing this, we can actually get whatever balance of the address that we give. So let us go ahead and see how it actually gets implemented in our code. One second, I'll switch to my VS Code window. So again, any further doubts that you might have regarding ethers.js, or if you are even after I try, you are unable to understand certain bits, what you can always do is you can hop onto this ethers.org website. You can search what that particular line of code is doing. Since this is the official documentation, it is like the best resource to learn ethers.js. Quickly moving to my window. Yeah. So here I have that line copy pasted. And what we need to do is instead of ethers.eth, we have an address. So we'll just replace this with address. And what that address points to is this one over here. We'll just put that in quotes. And yeah, that is pretty much it. And to print the balance of that, like how much balance that we have, we use again this function called console.log. So what this does is this prints the like the ethereum balance of that particular addresses. And okay, format units, again, format units is because whenever we are getting this balance is in v, like wei, that is the like the smallest possible ether that one can get. So if I straight away print balance over here, it will be a huge value which will actually not correspond. You can go to a simple V to Ethereum converter and convert the value, but that is what this line of code is doing. It is giving me the balance with 18 decimal places. So otherwise, I would have to put a decimal place 18 decimal places behind. So what this line of code does is that it makes our job easier and it just does that for us. So everything up to this point is clear, right? Come on, guys, just a quick motivation. Yeah, thank you. So again, so we can try and run this code. So using the terminal, so we'll write node. So again, because we are running this code directly in Node.js, we'll like just write node examples is the folder, and one underscore accounts dot js is our file. Okay, some error is there. Okay, sorry. I haven't. Okay, this small. Sorry, because I just copy pasted the code from the website. It is small URL over here, but the R variable is all caps. So we'll just try and fix that. Okay. Yeah. So the ether balance of whatever account that we have put over here is 7.0439. Rich guy. So let us go ahead and verify on Etherscan whether whatever code that we have written is correct or not. So just give me a minute. I'll share the Etherscan window. Over here, if we go, and yes, we can see 7.0439 is the actual value. So now we have learned that using ethers we can fetch any data that is available on the blockchain and make it somehow interact with whatever javascript code that we write. So this is a very simple code that I have some other examples as well, but due to the time crunch I did not want to go into them. where I'll be sharing all the code and the documentation so you can go through them in order to make your concepts a bit more polished. So yeah, that's what you can do. And I'll just quickly show the format unit where this that is there on the, yeah. So as I told you, so what we have, the value is in V. So to convert that into like ethers, we just pass it and we divide it by 18. So yeah, and you can have a look at other ethers library functions as well on this documentation link that I shared. Anybody wants to try like our code with some other address that you find on etherscan? Wait, let me do one thing. I'll just give you etherscan.io. Let's just try this. Okay, go to this website and give me any address that you find. Is anybody doing it? So I'll wait, and once you give the address, we'll try and find whether our code is actually working or not. Just go to the website, go to transactions, and copy any address and give it to me. Okay, so yeah, we do have an address over here. So Sagarika has shared an address with us. Let us try and copy this and change our code over here. Okay, so and Natasha has also shared. Okay, Natasha, I think your address seems surprisingly long. We'll try that, but just make sure that it is not the transaction hash and actually an address of someone. So just go ahead and check that once, and if that is, we'll just check that with our code. Yeah. So here, if I just change it to the address that Sagarika shared, and I just save it and run my code again. So it is zero ethers. Sagarika, can you just confirm that whether it is correct or not? Just give a thumbs up if that value is correct. Okay, yeah, that looked like the transaction hash, Natasha. So I'll just go ahead and put this address over in my VS code, and we'll just try and figure out what the Ethereum balance is. 30 ethers, damn, crazy rich. Natasha, is this your account by any chance? Damn, 30 ethers is very rich. I mean, just confirm. Yeah, yeah, I mean, that was a silly joke, but just confirm whether the value is correct or not. Like when you actually go on to Etherscan, is 30 ethers that the amount that you see? Okay, let's just, I'll only try and do that. It is showing, okay, not the value in dollars. Uh, the value in ethers. Can you check with that? of this particular address. Okay, is that it? So we'll just try and run it again. Okay, now it is showing us 30. Let me try and hop on to Etherscan and check. Okay, now when I go ahead and check that address, it does show 30 ethers as the balance. Are you sure that it is showing 0.029? Like, can you check the address that you have sent is matching with the one that you have put on the chat? Because when I try and log on to Etherscan, just try and share that for you. So yeah, here it does show 30.136, which is the value that we are getting. Maybe like there might be some issue. So just try and run this code on your PCs as well. Just put in different addresses and check whether the values are matching or not. Now that we have a basic idea of how ethers.js looks, we'll try and run different tests on the codes that we have written. So just give me a minute and I'll just write the tests and share the screen. Okay, yeah. So, so can you see my code? I've just created a new file, property escrow.test.js. So whenever we are creating new test files, which will actually test our Solidity contracts, we write them as like the extension should be .test.js. .js because JavaScript is the language that we use to create our test files. So going from the top again, so chai and hard hat again both are different libraries, and chai is actually something that we use to check that the value that we are actually getting and the value that we expected are actually the same. And now describe again is a mocha function. So it like mocha test runner is the test runner that comes along with hard hat. So whenever we are running tests, it is done via mocha. So I have one describe property token function, and that just initializes a bunch of different values. So yeah, that is how this works. So all these are like different values that we are trying to initialize, and apart from that, const time is actually like again a hard hat helper that is there for manipulating the chain's clock. So yesterday when I was showing you the demonstration of the code, you might have seen that whenever I tried to, like, say, uh, I tried to run my code. There was some issue because the deadline was 19th of April, but because I was doing it on the 18th of April, that is yesterday, I was not able to finalize and the status was showing as funding. And for our testing purposes, if we ever want to, like, manipulate with the timing, that is what we do. And now moving on to the before each. So this test is something which will run before each test. So that is how the name is, and that's what its function is. So here again we have a bunch of different values, and again, get signers is like we are getting all the signers by name. So we are indexing them, and the signers 0 will refer to operator, signers 1 will refer to investor A. That is how it makes our array. Apart from that, like, const escrow is there. So, like, it just attaches to the existing deployment, and we can take a look at the contract name. So at the last, as you can see, get contract. So if we give any property token and its particular address, it will give us the contract. And within the escrow, it is just like the values that we defined earlier: the address, the goal, duration, and some, like, just test values we have given a test value for the flat name, we have given a test value for the token name. So actually the test value for the token name is Burj Vista 2304, and the token symbol that we have used is BURJ-2304. So we are just giving simple test values, and that is why we are running it as a before each, so that before every test that runs, this is a test that should run alongside it. Now, moving on to the other tests that we have. Second. Yeah. So again, describe deployment function is the function within which all our tests are written. So, and it is like the way to define any test. So within it, what we write in brackets is what the test is actually trying to do. So here we can see the first one is like trying to, like, check it that it stores immutable metadata correctly. So it is just checking that using this equal to. So this equal to is what we get by importing chai. So this is just checking that all of the values are what we expect them to be, and that the account is not actually finalized till now. Now, the second one actually confirms cross contract relationship. So here, if you can see, like, the escrow variable matches that of the actual address. So when we test, like, it is just checking to, like, operator cannot be 0, and that it should actually match the address that is actually deployed. Now, again, so we have the contribution test, accept contribution and update totals test. Wait. Yeah. So these are just a bunch of different tests. You can go ahead and read them, and like, just try and get to understand what each of them does. So this is pretty much like simple JavaScript code. We are using the ethers library somewhere. So like here, ethers.parse ether, we are checking the value. So if it is actually after the deadline, so we are putting in that much time increase. So let's say if it is a 1 month deadline, so 1 month into 24 for hours, 60 for minutes, and again 60 for seconds. That is how this actually works. So this is 31 days, and then it just checks that it is before the deadline, and you can just go ahead and look at them, since I also want to deploy this code in today's session only. So I don't have time to go through all of this, but again, just try and go through these JavaScript codes, And if you find any like issues with being able to understand these, just tell us on the WhatsApp group. Even after today's session, I'll be available, so if you face any difficulties, I can answer that. But this is a basic structure of how we write tests. We write it block, then we define what the test does, and then we write what function we want to execute with that test. Is this much clear, like how we are writing tests? Just the basic overview of how the function are defined, where we give the names. Is it fine? Okay, great. So I'll just like bring the other two test files as well over here. Or wait a minute, I'll actually open the master folder that I have, so that we can quickly go through all the codes that we have without wasting much time, and then we can move on to the deployment. Just give me a minute. Yeah, just a minute. Are you guys able to see my screen? So here I have all the three tests written. So we just went through this property escrow.test, and let me just quickly show property token.test as well. So again, we are importing chai, we are importing hard hat, and again, before each test, what we are trying to do is like we are just like getting the signers, and we are just checking whether the property token is there or not, and we are just assigning values, like just test values to those property tokens. And that's like, and let me just quickly show the, so again, all of these files, what they do have is they have a bunch of tests. So this is one test, this is another test, and what our basic aim is, that my code should be deployed only when all these tests are running, and all these tests give actual like all these tests are passed. So then only my actual code should be deployed, because again, as I told earlier, again, like it is very difficult to change the code once it is actually deployed. So again, here we have a bunch of different like test functions. So one is the operator management, then we have, what else do we have? We have list, again in listing properties, like authorized operator can list a property. So we are checking whether the operator can list a property or not. And again, here we have unauthorized address cannot list. So if it is not a operator, it should not be able to list the properties. And again, we are checking a bunch of different values along with that. So we are taking, these are just variables. So token address is a variable, token is a variable, and we are trying to run different tests on them. Is it fine? So these are the three test files that we have. And now let us go ahead and look at the front end code. So all the front end code would be actually packaged within this src folder. Let me just first quickly tell you how to initialize this front end folder, so that when you are actually coding, you don't face any issues. Just a minute, I'll tell you how to initialize, and then we'll just quickly look at the different codes that are there. So yeah, here as you can see, I don't have anything in my front end folder. So in order to initialize that front end folder, just give me a minute. We'll have to run certain commands. So I'll just show them to you, like what all to run, so that you can actually uh, get your front end setup. So yeah, this is the command that we run. We don't need front. Okay, no, first we'll change our directory into the front end folder. So we'll just do cd front end, because right now we are in contracts. So we'll just go back and we'll do cd into front end. Now that once you are in the front end folder, what you would want to run is the npm create command. Just remove the front end because we are already in that folder, and this will just create a template react project in our front end folder. So need to install the following packages. Just do y and enter. So project name would be front end. Install with npm and start now. Just go ahead and do yes. So yeah, I mean, I could have done it in the main one as well, but it just created a front end within my front end. So that just initializes your public, your source. So source will have assets and the index.css, index.html. All of those is created. So these are just boilerplate codes that we get when we create one. So installing dependencies with npm, so it will install all our dependencies. So when you create a project, it will actually do so. And two more dependencies I want to show how are they installed. Just let me finish for this to get installed, and then we'll do. Yeah, so it started running, and if I click on this link, it will actually open a just a template react folder. Let me show how that looks. Obviously that's not what we want, but just to get an idea. So yeah, this is how it currently looks. So I can explore Vite, I can learn more about React. So whenever I initialize a project with React, this is how it looks. And now we'll be installing some more dependencies. So I just want to show how that works. And once that is done, we'll just quickly look at the codes. So again, here I can just do control C to get my terminal line back, and I'll do npm install to just install whatever packages that are there. But since here they have already installed a bunch of dependencies for us, if there would be any other dependencies, I can run it by running the command like npm install. But for now, what I'll run is, just a second. Yeah. So since I want ethers as a library, I'll run this command as well. So this will just install all these libraries that are present over here, and after that we'll just install the Tailwind, because Tailwind is again one of the most popular things to work if we are doing CSS. So now Ethers is installed, and we'll just go ahead and install Tailwind. So as you can see, whenever like we have new things, our package.json will get updated, so all the dependencies will get added over here. So yeah, this is the package.json for this one, the front end. So now we have Tailwind CSS, Post CSS, Auto Prefixer. So these are just good libraries to have. And once we have Tailwind installed, we'll just initialize it with this command. And so it will create the config file. So tailwind.css.config. So similar to that, we had a hard hat config. So yesterday when we tried and installed hard hat and set up the hard hat contracts project, which gave us all these folders. Similar to that, for the front end folder, we'll need to install React, we'll need to have NPM installed, and we'll just install Ethers and Tailwind and bunch of other libraries and just initialize them. So this will give you this boiler like template in the folder. And once we are done with that, we can actually go ahead in the SRC and start coding whatever components that we have. So clear till now, right? Whatever that I have told about initializing the front end folder. Great. So now we'll go ahead and look at the codes in the front end folder that is actually there. Wait a minute. Yeah. So here is the front end. And as you can see, again, I have all the files. Like these get created whenever I initialize a new React project. And within this, what I particularly want you guys to focus on is the SRC folder, because this will actually have all our components and all our contracts. So in contracts, what we do is, I'll come to this in a second when we are actually deploying the code. But for now, just see like this create property is there. So this will actually open the form in which we are creating the property, and just like that. So I'll just go through in whichever library we are using ethers.js. I'll go through them, and others you can just try understanding React on your own. Or if you're well versed with React, this will be actually pretty easy code for you to understand. But for now, let us just focus on ethers.js. So we'll go to this utils, and in contract, that here is where the main implementation of our ethers is there. So factory address, factory ABI, again, we'll understand this when we are deploying the code. So factory address, as you might try and figure out, something related to property factory.sol and something related to an address. So you can try and figure out from that. And ABI, again, in the first session when we were exploring Remix IDE, we know that Remix IDE gives us an ABI. So this ABI is essentially the same thing. We need the ABI for the factory.sol contract, we need the ABI for the escrow.sol contract, and we need the ABI for the property token.sol contract. This is what it does. And so browser, okay, first let us understand these. So browser provider is actually like in Ethers, it will help us to connect with MetaMask. So it will help us interact with the MetaMask window. And again, this contract class is just like it is representing a deployed contract. So whenever any, we want to call any function from a contract, we need to import this from the Ethers library. And JSON RPC provider, as we learned in the previous, like a few minutes back, when we were doing that account.js file. So whenever we want to connect using an RPC like Alchemy, we will use this JSON RPC provider. And all these functions are from the Ethers library. If we want, we can import the entire library as well, but that just doesn't make our code as optimized as it will be now. So here again, we have a bunch of different functions, and so 6 factory functions are there. So those will just build them. And so these get read provider, get signer, those are actually the functions that are defined in the ethers.js documentation. So once you go to the documentation, you will understand them better. Now, like, instead of using ethers directly, we'll just go like factory address, factory ABI, that will point us to the our contracts over here, property escrow dot property factory dot sol. So it will point us to this contract when we are like going. So this file, essentially what it does is it helps us to uh, communicate with the contracts that are there, and all the functions will be related to that only. IPFS.js like doesn't have, so IPFS is another like thing. So when we have large files, let's say we want to uh, put pictures of our websites, so that is where this the full form is planetary file system or something, I guess. So that is what it is. So in Web3, it acts as the primary storage. So whenever we are trying to put some content which is data heavy and which might have large storage requirements, we use this IPFS. I haven't done it till now, but if you want, if you guys want, you can go ahead and try and complete it. If you want, you can take some data and you can try and implement it over here. So that would be a nice moving forward. So once you have understood the project till now, what you can do ahead is try and implement IPFS. But let us just stick to ethers like for now. So again, in the contract, all these are factory functions of the ethers.js. Now let us move on to this create property one. Just a minute. Yeah, Sean.
Could you explain like where do we paste like paste the alchemy key again on which code?
Yeah, I'll come to that when we are actually deploying the code. So if you see this env.example, there is so this is not the actual link. See, it is just your key here. But what we'll do is we'll create a new file .env. Like you must have seen, like when we were doing the previous one, the account.js file. There was one .env.example. Then we copy pasted that into a .env, and within the .env we'll actually paste our API keys.
Okay.
The ABI will be pasted over here. So these contracts, so .json file, here is where we'll paste the ABIs. I'll come to that in a few minutes from now.
All right.
So yeah, now like in the create property.jsx, again you can see we are importing parse ether from ethers. So parse ether, again, if you go ahead and look up the documentation, it is just to convert V into ether or ether into V. I'm not exactly sure right now. So format ether and parse ether are actually two functions. So one does ether to V and one does V to ether. I'm slightly jumbled up right now as to which is what, but you can just go ahead and search them up. But yeah, apart from that, so here we can see where all the implementation is. So here, parse ether, whenever we are using parse ether, we are calling the ethers JS library and that exact function we are using. Apart from that, sorry guys, I'm having some trouble with my internet over here. Uh, just moving forward from where we were. Yeah. So create property dot. So here all we are using from the ethers library is this parse ethers function. Now again, let us go on to our next, the property card.jsx. So here, as you can see, we are importing format ether. So format ether is the opposite of parse ether. So let us say, okay, so if I have a value in y, it will become in like ethers. So this is the same. The format ether is the same function that we called when we were learning about ethers a few minutes back. Now, apart from that, even in property list, so we are using this React router DOM and from ethers. Wait a minute. So there are no direct imports, but over here. But if you look at the, wait a second, factory, yeah. So whenever we are calling this factory and factory read only method, this actually import goes to the utils.contract.js. So this contract.js file, it will go over here, and because here we are importing all these methods from the ethers library, that will again get shown in the property list. Now apart from that, this file, so again, here we are calling both format ether and parse ether. One will give us ethers to V and one will give us V to ethers. Uh, Apart from that, I think in maybe portfolio also we would have used. Yeah, again here, format ether. Just to show the value in the portfolio page in a nice way, we are again calling this format ether from ethers. And apart from that, this is just a bunch of JavaScript code. Any LLM will vibe code this for you. So, but the major interaction which is happening using the blockchain is one, this ethers library. The second one are the this contracts file. So this is entirely which is interacting with these solidity files that we have over here. What is the- We'll just go ahead and see. So now, apart from this, scripts we don't need to. So if you want to deploy it directly, you can call this scripts thing. But since we will be manually deploying each and everything, we don't need to go through that. So let us just take a 2 minute break. If till now you have any doubt, you can ask. So at 7:20, we'll start with the deployment of our actual code. Is that fine? Anybody wants to ask anything? It can be anything general about the Web3 as well. Need not be related to the code that we are discussing right now.
Can you like send the final zip file after we are done with the code? Like,
Yeah, yeah, today I'll send. So what I'll do is, because once I already install the dependencies, the file becomes very large. So I have already zipped the file, but just make sure to follow the process right now. So because right now I haven't installed the dependency, so I'll just
okay,
be showing how to run npm install and moving forward with that.
okay.
Apart from this, anyone? So just give me a minute. I'll open the folder and I'll start sharing. So no doubts apart from this till now, right? So yeah. So what we would want to do is, first we'll move into our contracts folder and set that up. So we'll just run an npm install. What this npm install command does is it reads through this package.json and it installs all the dependencies that we want. So I have just zipped this folder. So after this session, I will be sharing this for folder with you guys, because once we install the dependencies, the file becomes very large. So in order to prevent that, I've just zipped it right now. So this npm install will just run, and we have to do this for both the contracts folder as well as the front end folder. So once this just finishes, I'll move on to the front end folder and show you for that as well. So, I mean, these warnings are not big of an issue. Many times they come because, like, we are using older packages, or some packages might be conflicting with the things that we have already installed in our computers. So, many times the dependencies are clashing. That is not something to worry about. We'll just change into front end, just go back and yeah, so in the front end as well, we'll run npm install. Again, this installs whatever is there in this package.json. So all these dependencies it will install, and after it is done installing, it creates this package lock.json, so that we know that okay, we told the installer to install all these files, and it actually successfully installed all these files. And once it is done, we'll see a folder called node modules in both of these. So these are the actual node modules that are installed by running this npm install command. So let me just quickly go back to my contracts folder, and now we'll actually run the hard hat commands. So we'll first compile. So to compile the code, now this is very similar to what we would be doing in Remix. But since we have our own JavaScript code as well, we just run npm npx hard hat. Sorry for that. Npx hard hat. Uh, so yeah, npx hard hat compile. Now what this will do is this will create a artifacts folder. Yeah. So here we have all the contracts again as a JSON file. So once we are done compiling, can anybody tell what we used to get when we did all this on Remix? Once we compiled the code, what did we get? Okay, we got the ABI and the bytecode, right? So that is what this creates. So the JSON files you see within the artifacts folder, these JSON files, this is the ABI for our property escrow.sol. See, this is the ABI. So that is what this does is, so this just creates, compiles all our code and creates the ABI for them as well. So npx hard hat compile is done. Now we want to go ahead and test the contracts. So whatever tests we have written in the tests folder, those will be run when we run this npx hard hat test. So see, all the tests, so these are the different tests. So within property escrow, the deployment tests, three were there, all three were success. In the contribution section, there were one, two, three, four, five tests, all the tests passed. So once we are able to run this, like all the tests are passing for all the files, we know that okay, our code is ready to deploy. I mean, we can finally deploy it on the thing. So for that, what we'll do is there is one more tool called Ganache, which you can use to start local blockchain. So blockchain on your local PC, but we'll do that using Hardhat itself. So just go to a new terminal. Why? Because we want this to keep running while we are trying to test our website. We don't want the and once it is running, you can't give any new commands. So for that, we just created a new terminal, and again we'll change into our contracts folder. So once we are in the contracts folder, we'll do npx hard hat node. Sorry, this just tells me all the command. I forgot to add node. So this will create 20 new accounts. See, from 0 up to 19. So 20 new accounts are created, each with a balance of 10,000 ethers. So again, this is a local Ethereum I'm running. This is not even a test net. Test net again, that is not really linked with the actual Ethereum, but it is a actual blockchain that is being run by various validators around the world. But these accounts over here, they have created a blockchain which just runs on my local PC. So I will need this account zero, because this account zero is the one that I'll be like creating as the uh, operator. So I'll use account zero to create new property listings, and I'll use account one to like invest those properties. So we can just leave this terminal over here and make sure not to stop it, but to let it keep running. Because now if I want to give any command, it will not go. So many times what people do is they do control C, but now all these accounts that I have stopped running. So they won't run right now. So I'll have to again start my hard hat. And again, these are the accounts that it will give. Okay, so I have to leave this running. Coming back to my main terminal, so I know that okay, all my tests have passed, my local blockchain is running. Now to create a RPC, because we haven't deployed it on Alchemy yet, it is my local blockchain. So to get the RPC for that local blockchain, this is the command that we put. So now this makes us go into the hard hat console, and we'll gather some values over here as well. So in this line, the first command that we would be putting is this. So again, this, if it gives undefined, it is fine. So uh, we'll just wait, and we'll give all the commands one by one, and we'll find the factory address. So this is the next one, and then this. Now that we have run all these are just simple JavaScript code, guys. Okay, so nothing some not some very advanced stuff. Once we have done all this, see, this is factory.get address, so it should give me the factory address. And console.log is just like a print statement. So when I run this console.log factory address comma factory address, it will give me the factory address. This factory address is important again. Why? Because I need to paste it like over in the code as well. So let me just quickly show you where to do that. So in our front end code, in factory.json, see here, we need to paste this factory address. And once we are done with that, we'll also copy paste the ABIs. But before that, here only, we need to run a few more commands. So we will, like, we have to authorize account zero as the deployer, right? So uh, wait a second. Yeah. So this is the code for that. Just copy paste all these codes. We would be giving these as well. So so yeah, this prints true, meaning that okay, we have created one operator. And again, see here, if I show you, like, okay, yeah. So from this address is actually matching my, see here I am getting new transactions as well. So if I see my 0f39, and here also this is from 0f39. So this means that this account has been verified as the operator. So whenever I go on to MetaMask and I sign in with this account zero, what I'll see is the operator badge next to my account. No, we have done this. So now what we'll do is we'll copy paste the ABIs for each of the files. So if you see over here in the front end, I need the ABI for escrow, I need the ABI for factory, and I need the ABI for token. So first let me do that for factory, where we'll find the ABIs within the artifacts over this. What I needed is I need for property factory. So I'll go to property factory.json and copy this entire ABI. Yeah. See, you get the ABI as well and you get the bytecode also. So these were the two things that we were getting in Remix. And similarly, like when we are deploying it in our local PCs as well, if we use hard hat and we compile, we'll get the ABI and we'll get the bytecode. So again, we go here to property factory.json, and instead of this, we just paste our current ABI. So this is done. We do the same for property escrow. So we go over here to property escrow, we copy the ABI. So why this copy and paste of ABI is necessary is because this is just the ABI that was generated after the compilation. If we want our front end code to know what that ABI is, for that we need to do this, like copy and paste the ABI in a JSON file within the front end folder as well. So just, yeah, I copied it from escrow and I am in escrow. So I'll just paste it over here. So this is for the escrow one. And finally for the property token.sol, I'll copy this ABI and paste it over here. So all the APIs are configured, they are set up, and our front end code also has the ABIs from our contracts folder. So just go ahead and do a control S, but no need to do that. Now we'll go ahead and set up MetaMask. Okay, and in MetaMask, I'll show you how can we add different networks. So because we are using a local hard hat network and not any test network that is publicly available, we need to configure that in MetaMask as well. So I'll just create a new Chrome profile. So let me switch over to my Chrome window. So again, so I just start with MetaMask extension install. Oh God. So we'll just go to this Chrome Web Store over here and we'll click on Add to Chrome, Add extension. Now this prompts us to, I'll just create a new wallet and import the one that I have, because when I click on I have an existing wallet, it will ask me for the recovery phase. Since I don't have a recovery phase yet because it is my local network, I'll just create a new wallet. I'll use this secret recovery phase. I'll enter some password. Now again, this password is very important because if you lose this, you lose access to all your. So if anybody remembers this, they can just steal all my ethers, but doesn't matter anyway because those will be my local ethers. So I'll just take a screenshot because it'll ask me to give those values. Yeah. Now here we don't want to interfere with this account over here. What we'll do is we'll click on add wallet, import and wallet, and here we will give the private key of our like account 0. So we go to the VS Code. I'm not switching it again. Just make sure that you go to VS Code and you copy the private key of account 0, not the address. Address is the one which is publicly available, and private key is the one that actually makes MetaMask know, yeah, okay, this is an authorized person. We discussed this public key and private key in the first session. So yeah, my wallet is imported, but now the issue is I can't see anything. For that, I'll go to networks and I'll click on add custom network. Now whenever you initialize a blockchain using hard hat, it is a definitive URL. So you just do hard hat local, name we can give anything. We'll do add RPC URL, and the URL is always http colon / 127.0.0.1. So this is the normal thing, and the port it uses is 8545. So whenever you create a new hard hat local blockchain on your device, this will be the port that it will be using, and we'll just give it some name like hard hat RPC. And chain id is again a like standard value. So yeah, this 31337 is the value, and currency symbol we'll give as ETH. Hmm, okay. 127.0.0.1. Go ahead and do save. So hard hat local was added successfully. Yeah, I see the 10,000 ethers, but because again I did some transactions over in my VS Code, I tried to like authorize myself as the owner. So that authorization costs us some gas. So which is why I am seeing my account balance as 9999.997. And I'll quickly import another account as well, and that will be my account 1. So that would be our investor. I'll go ahead, copy the private key of account 1 and paste it over in MetaMask. So yeah, here you can see this one has all the 10,000 ethers because this is not our operator account. Since we did some transaction in this account to authorize this account as the owner, I mean operator, that is why it costed us 0.003 ethers. Is everything till here, Crystal? Just give me a quick thumbs up. Okay, great. So now that we have it running, the only thing left is to run our front end. So for that, let me stop this. Let me share my VS Code window. Yeah. So see, from here I copied the private key of account 1 and I copied the private key of account 0 when I was importing them in MetaMask. Okay. And here we also want the hard hat to keep running. So I'll just create a new terminal and I'll do cd front end and I'll do npm run dev. Npm run dev is the standard command if you have ever done any web development. You do npm run dev to just start your website. I'll just copy this because I'm using a different Chrome profile. So I'll copy this and I'll paste it. Otherwise, you can do command and click as well. So that helps. Now I'll go back to sharing my Chrome window. So npm run dev is the only command after the hard hat commands that we ran, and that should open your file. So here we get this, and when we click on connect wallet, it will ask us. So I can edit accounts over here. So I can connect both the imported accounts in one go only. So imported account one, as you might know, is my operator account, and this is just a normal account, so I can make it act as the investor. So I go ahead and I connect both of these accounts. I click on connect, and it shows wallet connected. So now when I'm on imported account one, I can see the operator badge over here, which means that I am the operator. And I also see this list property. So again, I can create a goal, I can create a duration, I can give a name, I can give a symbol. So let us say test flat, and all these values are good to give, but it is not necessary. As I told you, IPFS, interplanetary file system. So if you are using web3 apps, it is and you implement pinata, you can do that. But since we didn't have time during these 4 sessions, I didn't show you how to do that. But you can always try and figure them out yourself, and if you face any issues, you can post in the group. So let me give a goal, let me give a duration, let me, so this token name, let's say I'm giving test Ethereum, and I give this as TETH, list property. So now it will ask me to sign a transaction. And again, see, this network fee of $6.4 is essentially the gas that we discussed in the first session. That all the transactions that run on the EVM, the Ethereum virtual machine, they need to give some gas. So this over here is the gas that we need to give. And we just click on confirm, and it shows the property listed. So if you, I just show my VS Code terminal to you, we'll see. Yeah, now since the property got added, and we can see the address of the account that added this property, 0f39f. I can see over here 0f39f is actually the account that added this. And I'll just quickly change the account over here and show that as well. So okay, as soon as I change the account, see, the operator badge is gone, and the list property is also gone. And if I say I want to give 30 ethers as a contribution, I click on contribute, I authorize this transaction. See, listing a transaction on the Ethereum costed us much more gas. So that was around 6.4. But since this is just a contribution and I'm not listing any new property, the network fees is quite less than what we gave earlier. So I'll just click on the send 30, and it has done contribute. So my balance goes down by 30 ethers. Although if I go to the other account, that should be updated. 0.9. Okay, no. So since the goal is still pending, it has gone in the escrow account. So if I just change the date and time of my PC and try to play along with that, it will happen. But yesterday it uh, disturbed my internet pretty bad. Like I was being removed from the meeting again and again because the date and time doesn't match. So I won't do that today. But yeah, that is how you connect MetaMask, and you can just change accounts. So here you can see I'm not an operator, but as soon as I switch to my main account, I become the operator. Is this fine till now? So I'll just show that uh, my VS Code window once. See, here whenever I do, the new transactions are getting listed. Earlier, what I had was I just had the list of accounts, and my thing ended at the warning. But now, whatever new transaction I do, I can see, okay, this is my first block. This much gas is being used. This is my second block. This much gas has been used. This, then again, 2, 3 transactions getting bundled up, and they will create a third block. So this is the thing that we learned in session 1, where we saw that Bitcoin visualizer. So there can be many transactions that get finally packaged and get sent as one block. Next, I have these many transactions, some 2, 3 transactions, they were added as one block over Where? See, over here, block 4 was added. So all these transactions that were after block 3 and before block 4 are bundled in block 4 and added to my local blockchain that I have. Now, there is a slight crunch of time, but I'll give you a basic idea of how you would deploy this actually on a test net and like the front end on Vercel. So like we have already done npm install, we have already done hard hat compile, we have tested all the contracts and the front end file, the abis we have copy pasted, and we have all those things done. So I'll just create a new metamask account. Like I will be using sepolia, so I'll just quickly show you how to do that as well. Because this is our local blockchain. If I want to run it on a test net, the most common test net that people use is Sepolia. So over here also, if you can see, if I go to my normal account and I go to networks, I just need to switch on this show test networks, and it will automatically, if I just click on save, it shows Sepolia was successfully edited. And if I go to a Sepolia proof of work faucet, there are many faucets. So in the first session, we use the Google faucet, but proof of work faucet is usually fine. This Google Cloud faucet also you can use, but for now we'll just do this. We'll go here, we'll go to account details, and we'll click on private keys. Give your metamask password, give here, and just copy the ethereum address and paste it over here. Sorry, we don't need to give the private key. Sorry guys, I just we just need to give the public key, because to receive ethereum I don't need to give my private key. I'll just authorize this. I'll click on start mining. You are connecting. Click on the tool. Wait a second. I think I have my VPN running. Yeah. So it'll just mine. So let me just increase the number of workers. While this is running, I'll try and use the Google faucet as well. The only caveat is that using this, I'll have to put in my Google account. Or does it work without that as well? Yeah, you are signed out. I'll just sign in and put in my uni mail. I'll just copy my Ethereum Sepolia address and paste it over here. As you can see, I can see Sepolia ETH over here, and this is Sepolia faucet. So I'll do get point. Here also I've got 0.85 Sepolia ETH. I'll just do stop mining and claim rewards. I'll do claim rewards, and the transaction is in queue right now. So as soon as it gets processed, I'll see my balance update over here. Yeah. So I have got zero point 0.5 from Google as well and 0.085 from here. So my net balance right now is 0.135 Sepolia ethers. Now we'll try and utilize that to just deploy our code on the Sepolia testnet. So for that, the next thing that we need to do is like we want a Ethereum Sepolia Alchemy uh, we need an alchemy account as well. So I'll just use my normal alchemy account. I'll not create a new one. So like we did when I was doing the ethers.js library. So just go to alchemy, create a new app, and just we'll name that app. Wait a second. Uh, yeah. Again, I'll go to alchemy. I'll create a new app called, let's say, real estate app, and we'll do next. We'll choose Ethereum. We'll do next, and we'll do create app. So again, this is from here we change the network to Ethereum Sepolia, and this changes our API key and our endpoint URL. But while I'm at it, I'll also create a like API key of Etherscan because we would need that as well. Etherscan API key, just click on that. By Yeah, sorry for the interruption, guys. So I was just connecting my VPN, and if I just refresh, yeah. So if you are also unable to access Etherscan, you can just if I just sign in, I should get a API key and we'll sign up over here. So yeah, I'll just do a quick sign in now. So yeah, now if I head over to API dashboard, I can get a free API key. I'll just click on add, and I'll give the app name as real estate dApp, create new API key, and I'll just copy this API token. So I need one Alchemy API key, I need one Etherscan API key, and I'll need the private key of my Sepolia funded faucet. So where I have to add this, I'll have to create a env file in my front end, I mean in my contracts folder, and there I'll paste all these values. So let me just show my, if you guys want, what we can do is, if you want me to end the meeting at 8, I can record this as a video and post it on the group. Or else, if you want me to continue this meeting right here and show you how to deploy it on Sepolia, we can do that as well. Anyone, like, should I end the session right now or should I continue? It should take about 10 more minutes. Just raise your hands if you want me to continue, else I'll end the meeting and I'll share the video with you guys. So it's fine if I end the session right now, right? We have deployed it using our local blockchain. I'll just show the window for that. So yeah, so this is like this website that we are seeing. It is because we are running a local blockchain in our VS Code, but how to list that on a test net is something that I'd be doing and I'll be sharing with you guys in by tonight. I'll do that, how to deploy it on an actual test net. And after that, yes, we would be done with the workshop. Right now also, I'll share the zip file. So what you can do is you can run hardhat on your local PCs and just use localhost to run the front end and connect it using MetaMask as I showed earlier. But if you want to deploy it on a test net and the front end on, let's say, Vercel, how to do that is something that will take around 20-30 more minutes. So I think I'll bundle it up as a video and share it with you guys. Is that fine? Some thumbs up in the chat, guys, if that's fine. Okay. So that's great. So this was our final project, guys. So this test flat that we have created, let me just quickly like import another account and show you how that works. So I'll just click on add wallet, import an account, and I'll go to my VS Code, copy the private key of account 2 over there, because account 0 is the operator, account 1 was one investor, and I'll just paste the private string of account 3. So again, I should see, okay, the network changed to Sepolia, but we were using our custom network, right? We'll just switch it off for the meantime. Wait, I'll just click on add custom network again. Hard hat local, add our PC URL. So the HPC URL was, yeah, 127.0.0.1 colon 8545 test app RPC, chain ID is 31337, yes, ETH, and okay. I already have it added. Okay, sorry. Yeah, I just save it as the hard hat. Yeah. Now it switched again to my hard hat network. So I can see all these accounts. Yeah. Now see, it prompts me that account 3 isn't connected. I click on connect account, and now I can see this is a property of which someone has already given 30 ethers. Now what I do is I just give 70 ethers I contribute, and it will deduct 70 from my account. And then what I'll do is I'll manipulate the date of my like computer and just show you for some time. After some time the net just gives up if I play around with the date. So it should work. I'll just show you for a few minutes how we can go ahead and finalize any property, like change the status from funding to actually like completed and all that. Let me change the date. So I've just set my computer to June, and if I switch back to the operator account, see I show finalize and receive funds. Now as soon as I click that, my account should be credited by 100 ethers. I just click on confirm, yeah. So as soon as I click on finalize and receive funds, if I wait for some time, yeah, my account was credited by 100 ethers. So that is how this worked. So till now, the funds were in an escrow account, but I just changed my date and I just showed like if this is working. So now the status changed from say in funding to the status changed as owned. So that is how this works. And so that is the entire thing. Now if I change the account to one of the investors, if I let's say change to account 2, and I go to claim 3 lakh 30,000 TETH. Why 30,000? Because in our initial contract yesterday, if you remember, we had defined that for every ether I will create 1,000 tokens. So for 30 ether I'll get 30,000 tokens. So I claim my test ETH, and I again confirm the transaction. Similarly, I do it for account 3 as well. Account 3, again, as you will guess, will get 70,000. Wait a second. I didn't switch. Uh, yeah, claimed 70,000 ETH. Once I do this claim, I'll again have to authorize a transaction. And once that is done, I'll get those 70,000. So again, these are tokens. These are tokens of the ERC20 standard, which I have. And if I go to my portfolio, okay, this is some error that I had fixed in a different code. So we can do that, but this port, the final thing that we'll be sharing, it will be fixed. But again, if you can see, I have 70,000 test ETH in this one, and I have 30,000 test ETH in this one. And this flat is the status is changed to owned. So this was the final demonstration of the project, and I hope right now you know how this works. Deploying on testnet and Vercel, I'll just create a short video and I'll share them with you guys. And that was it for today's session. Thank you for sticking around. Thank you for staying extra as well. It was lovely conducting these 4 sessions. I hope you learned something about blockchains, how they work, how to code in Solidity, and how to finally write JavaScript code and make it interact with the blockchain and run hard hat as well. And that was it for the this month's Microsoft Monthly. Please make sure to check your mails for next month. We might be delving deep into some other technology. Thank you so much, everyone.